Okay, so this is your acceleration study guide. So looking at number 1, it asks what the difference is between uniform motion and accelerated motion. Well, we know that uniform motion means that the object is traveling at a constant speed, which means it's going to go an equal amount of distance in an equal amount of time interval. Accelerated motion is basically any other type of motion. If it's speeding up, slowing down, changing direction, that's all accelerated. Anything except constant speed would be accelerated. Number 2, how would you calculate the speed of an object in the lab? We've done this many times. In the lab, we don't have a radar gun to just tell us the speed, so what we have to do is measure the distance and measure the time, and then we go and divide distance by time to get our final answer. So out here we could put equals speed. Number 3, describing 3 situations where acceleration can occur. We talked about how acceleration is a change in velocity over time. So if something is speeding up, its velocity is changing. If it is slowing down, the velocity is changing. And if it changes direction, the velocity is changing. So all 3 of these situations mean that the object would be accelerated. So now we're asked to take a look at these position versus time graphs and discuss starting point, direction of motion, and speed, whether it's constant, speeding up, or slowing down. So for this first graph, for starting point, number 1, I just look and see where the line starts. Looks like it starts at 2 meters. And then the direction of motion, it's moving away from this 0 mark right here. As the line goes, it gets further and further away from 0. So that means it's positive direction. And then the type of speed, it is a straight line, so constant speed. Over here, our starting point is going to be over here where time is 0, so you go ahead and follow this up. So our starting point is 7 meters this time. The direction of motion, the line is starting up here and getting closer and closer to 0 down here, so that means it's a negative direction. Straight line again though, so constant speed. Just looking at this one now, we're going to do the same thing, but as you can see, there are 2 different distinct areas of motion here. But that's okay, we can still describe everything. The starting point for this line is going to be at 4 meters, right here, it's your starting point. And then for the direction of motion, for this, we don't have a direction. It's not moving towards 0, it's not moving away from 0, so we don't have a direction for that time. But then it starts moving away from 0. So I just went ahead and wrote none and then positive. So if this is true, you have no direction and your position is staying the same. In other words, your line is flat. That means that the object is not moving. And then a straight line, we have constant speed. So stationary and then constant speed. So this graph is going to be something similar. Instead, we have 3 segments, so we have to talk about all 3 segments for each one. Starting point, though, is fairly simple, right up here. Starting point is at 9 meters. And then for your direction of motion, you're going towards 0, no direction, and then away from 0. So that's going to be negative, none, and then positive. So we have a straight diagonal line here, which means constant speed. The flat line is just like this flat line over here. None, no movement, and then a diagonal constant over here. So it was constant, then it was stationary, and then it was constant again. So on these, we don't have straight line, we have curves, which means we don't have constant speed. So your 2 things that you need to do are describe what the object is doing and what the velocity versus time graph would look like. So when I look at this one, I see very steep at first, which tells me fast, and then it's getting less and less steep, which means it's getting slower and slower. So overall, this object is going fast and then slow. So that means the object is slowing down. And so velocity versus time graph, first you have to decide whether the motion is in the positive region or the negative region. This is moving towards 0, so that means it's going to be negative, so down here in the bottom. you're starting at a very fast speed because of the steepness and moving to a slower one. So if you're starting at a fast speed, you want to start away from 0 and then move towards it, kind of like that. This one we have less steepness to start with, and then it becomes steep. So this one is definitely speeding up. So this one is moving away from 0, so it's going to be in the positive side of the graph. And it's going to start slow down here by 0, perhaps, and then get faster. Go away from 0. This one we have a fairly steep line at the beginning, and then it gets less steep at the end. So this one is slowing down as well. The difference between the top one and this one is that this one is moving away from 0, so that means it's going to be in the positive side of your graph, but it's basically going to be doing the same thing. It's going to start at a higher speed, so up further away from your 0 mark, and move toward 0 like that. This one, you have very little steepness to begin with, and then it gets steeper and steeper as you go, which means that it's building up speed. So that one's definitely speeding up, moving toward 0, so it's negative, so it's going to be down here in the bottom. It's speeding up, so you're going to start closer to 0 and then start moving away like this. This next section was to test your grasp on these curves, whether you can tell if something is moving in the positive or negative direction with a curve, and then whether you could tell what was really going on. Is it speeding up or slowing down? Because we know that anytime you have any sort of curved line going on, it's not going to be constant speed. So this is what you should have. There are a couple tricky ones. This one right here, you do have constant speed at the later half of the motion, but this little curve right here means that it wasn't constant the whole time. So I went ahead and said that it's speeding up. And this one right here, as you can see, starts off slow, gets super fast, and then slows down again. So you have kind of two different types of motion. So I said speeding up and then slowing down. So on these, you're doing the same thing. You need to ask yourself whether it's going in a positive or negative direction, or if it goes different directions at different times, and then what type of motion you have. So this is what it should be. The only real tricky ones are these two, and because they change direction in the middle of the motion, you have positive and then negative, and then you have speeding up, and then here at the top of the loop it slows down, and then it speeds back up again. So you have speeding up, slowing down, speeding up. So that's what I wrote in my box. This is basically the same motion, just in the opposite directions. Instead of going positive first, this one goes negative, but it's doing the same things because the steepness is relatively the same. Okay? So these are the things that are going to be covered on your quiz on Friday. Please study. This is a good opportunity to boost your grades a little bit. Good luck.